Okay, let's get into this. Our mission today is a deep dive into India's digital future. Specifically, its growing thirst for power. We're looking at a potentially huge policy shift here, thinking about nuclear energy, specifically these small modular reactors for data centers.
Right. Data centers are just exploding in terms of energy use.
Exactly. And AI workloads are really pushing that demand through the roof. So while renewables are obviously key, you keep running into that intermittency problem, right? And storage isn't quite there yet for the long haul.
Precisely. That gap needs something reliable, something constant, and low carbon. And that's where it gets interesting. India seems to be looking beyond just, more batteries or fossil fuels. They're actively considering small modular reactors, SMRs, as maybe a core part of the national data center strategy for long-term power.
SMRs. Can you quickly break down what makes them small and modular?
Sure. So small means typically 30 to maybe 300 megawatts electric per unit, much smaller than the big conventional plants that are often 700 or even 1,000 plus megawatts. And modular, this is really the potential game changer, commercially speaking. They're designed to be built in factories, standardized units.
Ah, like an assembly line approach.
Exactly. Factory built, then shipped and assembled on site.
So that standardization must tackle the big historical problem with nuclear, right? The massive delays and cost blowouts on construction.
That's the idea. It aims to de-risk it significantly. You shift from, a unique decade-plus construction project to something more predictable. Standardization should cut down construction time, reduce delays, give much better cost certainty up front. That makes financing way more attractive, especially for something like a growing tech hub.
Okay, but hang on. If the goal is reliable, safe power, why jump straight to nuclear, even small nuclear? Why not just, throw everything at bigger battery farms and solar?
Well, SMRs promise a couple of things. Batteries alone can't really deliver yet at that scale. First, continuous baseload power, 24/7. And second, enhanced safety features. Many designs use what's called passive safety.
Passive safety.
Yeah, they rely on natural forces, think gravity, natural circulation, convection for cooling, not complex pumps needing external power. It relies more on physics.
Okay, so inherently less likely to fail in certain scenarios.
That's the design philosophy, yes.
Right.
Reduces the risk profile compared to some older, larger designs. Plus, their size gives you flexibility. Scalability, you can add units as demand grows, like plug and play.
Right.
And importantly, you might be able to site them closer to where the power is actually needed, like data center clusters or industrial zones. Less need for those huge, long transmission lines.
Okay, let's pivot to India then. They've got a long history with nuclear 22 reactors running now, I think.
That's right. They're not starting from scratch.
So what's the specific push towards building these smaller, homegrown SMRs?
Oh, the commitment looks pretty significant. It seems tied into their energy independence goals, too. Serious R&D is happening at BRC. That's the Baba Atomic Research Center.
India's main nuclear research place.
Yep. And NPCIL, the Nuclear Power Corporation of India. They're working on designs around 220 megawatts based on PHWR tech.
PHWR, pressurized heavy water reactors. That's the technology they've already mastered domestically, isn't it?
Exactly. Decades of experience building and running those. So they're building on known strengths.
And is there serious money behind this vision? What's the funding look like?
Seems so. The union budget for 2025-26 apparently allocated a very substantial amount, at 20,000 crore, which is quite a lot.
Wow.
Yeah, specifically earmarked under the nuclear energy mission for SMR development. That signals it's more than just research, it's a national priority.
So concrete targets, are they aiming for specific numbers soon?
The targets are definitely ambitious. They're aiming for 5 homegrown SMRs pilots and early commercial ones by 2033. And that's really just a step towards this huge long-term goal of 100 gigawatts of nuclear capacity by 2047.
Okay, pulling it all together then. What's the core takeaway for you, the listener? It seems like this isn't just about swapping one energy source for another. It feels like a strategic tech play, right? Positioning SMRs as the reliable, zero-carbon backbone needed for this power-hungry digital future driven by AI and data centers.
Absolutely. And that leads to a really interesting thought to leave you with. Given this focus on homegrown tech, better safety, and putting these reactors potentially closer to cities or industrial areas, how might public perception change? Shifting from thinking about huge remote power plants to smaller nuclear modules nearer to where people live and work, something to think about.